So we will go over the answers to the review of the quarter test for Friday. These are the first of the 5 review questions. The first question says, find the distance between the 2 points, -5, 8, and 0, -4. Well, to answer this question, let's think about what it's actually saying. So we have 2 points, and we know that each point is defined by its x and y coordinate. So when we're given 2 points, we want to make sure we specify what our x1 is and what our y1 is, what our x2 is and what our y2 is. Once we specify that, we can graph them. And when we graph them, we see that if we draw a line, we want to find that distance. So that line represents, we'll write it in black, this is our d, or distance. Now in class we learned what the distance formula was, or distance equation. We learned that to be d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now we have to remember that as long as we're consistent with naming our points, it doesn't matter if our -5, 8 is our x1, y1, or if the -5, 8 we choose to be x2, y2. As long as we are consistent with our x and y coming from the same point. So now once we label our points and write our formula, all we have to do is substitute our information in. So we get that x2 is 0, so it's 0 minus our x1. Our x1 is -5, and that's squared, plus our y2, which is -4, minus our y1, which is 8. I gotta make sure that's squared too. Okay? We simplify our equation and we get that the square root is 5 squared, because minus a -5 becomes positive, so I'll write that in a different color. The minus sign becomes plus and our negative sign becomes plus. So we have 5 squared plus a -4 minus an 8 is a -12. Now the reason why I keep it in parentheses is to make sure that when we square it, we square the entire number, and our number is -12. It's not 12 squared and then a negative sign. After I square the information, the numbers, I get 25 plus 144. When we do basic addition, we get that d is equal to the square root of 169. And since 169 is a perfect square, it's a nice number, it comes out as 13. So our distance between the 2 points is 13. Alright, so for question number 2 reads, find the midpoint of the line segment connecting 6, 5 and 12, 9. Again, we are given 2 sets of coordinates that define points. So the first thing we want to do is we want to label our points. So we'll label 6, 5 as our x1 and y1, and 12, 9 as our x2 and y2. Now they're asking us to find the midpoint. So let's see what the midpoint is. So if we graph these points, let's first graph 6, 5. So if we go over 6 and up 5, we are here. So I'll graph that point. That's 6, 5 and 12, 9. So we go over 12 and up 9, puts us right here. I'll graph that point. And if I connect those lines like so, what would our midpoint be? Now we see that our midpoint is somewhere between 9, 7. And I'll make that point. And it may be exactly 9, 7. But I don't want to say it's 9, 7. I don't want to say the midpoint is 9, 7 yet, because we're not 100% sure. So let's check. How do we check? Well, we know our midpoint formula. So what is our midpoint formula? Well, the x-coordinate midpoint, so mx, that's the x-coordinate for the midpoint, equals our x1 plus our x2 divided by 2. So let's find the x-coordinate first. What we do is we basically substitute the information in. We get 6 plus 12 divided by 2. And we see that 18 divided by 2 equals our x-coordinate. So we get the midpoint in the x-coordinate is 9. All right, now let's do the same thing for our y. Our midpoint y-coordinate is equal to our y1 plus our y2 divided by 2. Substitute the information in. We get 5 plus 9. So we get 5 plus 9 divided by 2. And we get 14 divided by 2. So our my is equal to 7. So when we write this, we can say that our midpoint is at the points 9, 7. If we look back to the graph, were we correct in our guess prior? Absolutely. We saw that before. The midpoint should be around 9, 7. And through algebra, we proved that our midpoint is indeed at the coordinates 9, 7. All right, so the next question asks, M is the midpoint of AB. The coordinates of A are -2, 3, and the coordinates of M are 1, 0. Find the coordinates of B. So this is just like the previous problem, except now we're only given one endpoint and a midpoint. So let's write down all the information we have. If we know that point A, so we'll say A is at -2, 3. And we can label that as our x1 and our y1. Then we have our other endpoint, which is B, except B we don't know what the coordinates are. So we'll label as our x2 and our y2. And then we have our M. And what's our M? M is our midpoint. So we have the midpoint as 1, 0. So the midpoint is 1, 0. And what can we label those? Well, we can label those our mx and our my. Now, why do we label it that? Well, we label it that because we have our midpoint formula. And what's our midpoint formula? It's the midpoint x-coordinate equals our x1, which is our endpoint, plus our x2, which is our other endpoint. And that's divided by 2. So now we just substitute the information in. We have an mx of equaling 1. We have an x1 of -2. And we have an x2 we don't have. So we want to solve for x2, and that's divided by 2. To make this easier to see, we can always put the 1 over 1, and now we have two fractions. We have a fraction equaling a fraction. To bring 2 to the other side, we have to multiply by 2. So I'll multiply by 2, and we can see that the 2's cancel, or 2 divided by 2 is 1. And we bring 2 to the other side. What we get is 2 equals a -2 plus x squared. Shouldn't say x squared, x2. To bring 2 to the other side, we add 2, and we see that the x-coordinate of our endpoint B is equal to 4. Okay, if we do the same thing for our y, we would be able to find the exact coordinate of B. So our my is equal to our y1 plus our y2 divided by 2. Our my is 0. Our y1 is 3. Our y2 we are trying to find, and that's divided by 2. Again, we bring the 2 over to the other side, we see that the 2's cancel, or, like I said before, it's 2 divided by 2, which equals 1. 2 is on the other side, times 0 is 0. And then we have 3 plus y2. To bring the 3 over, it's a minus 3, it's a minus 3. And we find that the endpoint B has a y-coordinate of negative 3. So if we were to write this, we can see that point B is at the coordinate 4, negative 3. Alright, so question number 4 asks, given the shape on the right, the coordinates are Q is 4, 5, U is 11, 1, A is 1, negative 4, and D is 0, 3. Find the distance of the diagonal segment AQ and find the midpoint of the diagonal. So what is the diagonal? Well, when we look at this figure, we see that A and Q is not connected right now. So let's connect them in, and we'll draw that in red. So if I was to connect AQ, I would draw a line from A to Q. That is AQ's diagonal. So here's the diagonal from A to Q, and that creates a segment. So we can label that, what we want to find, as D. So we want to find the distance of that new segment. So for the first question, we want to use our distance formula. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So remember, the first thing we want to do is we want to label our x2s and y2s and x1s and y1s. So we'll say that Q, which is at 4, 5, we'll label it up here as our x1 and our y1, and we'll label A as our x2 and y2, like so. So down here, all we do is we substitute the information in. So we see that D is equal to the square root of our x2. Our x2 is from A, so our x2 is 1, minus our x1, which is from Q, which is 4. We square that, and we add it to the y's. So what is our y? Our y2 is from point A, which is negative 4. And our y1 is from point Q, which is 5. So we'll put 5 right here, and we'll square that. Whatever's in the parentheses, we do first. So D equals, we see it's negative 3 squared plus a negative 4 and a negative 5 is a negative 9 squared. We simplify it further, and we get that D equals the square root of a negative 3 times a negative 3 is 9, plus a negative 9 times a negative 9 is 81. Finally, we see that D equals the square root of 90. And since the square root of 90 is not a perfect square, we can use our calculators, and we see that the square root of 90 is 9.49. So 9.49 is that distance between point A and point Q. Alright, so the second part of the question asks, find the midpoint of the diagonal. So what is the midpoint on that diagonal? Well, we know the two endpoints. So once we know the two endpoints, we can find that midpoint using our midpoint formula. So what is our midpoint formula? The mx, which is our x-coordinate of the midpoint, equals x1 plus x2 divided by 2 and our y coordinate of the midpoint equals y1 plus y2 divided by 2. Alright, so now what you have to do is just plug in our information. So we see that our x1, now the x1 comes from what point? It comes from point Q. So our x1 is 4, and our x2 comes from point A, and we see that that is 1. And we want to divide that by 2. So we get that our mx equals 5 divided by 2, or 2.5. Now for our y. Our y1 comes from our q, so it's 5, plus our y2, which comes from our a, is negative 4. And we want to divide that by 2. So we get that my is equal to 1/2. So our midpoint, our m, is equal to the coordinates 2.5, 0.5. And I'll box in the answer when we're done. Let's check that answer to see if it makes sense. If we go 2.5, which is here, and we go up 0.5, which is here, and I'll draw a little dot on our graph, that would be the midpoint of our line. And it does look like it's the midpoint. And lastly, question number 5 reads, what is the measure of angle 1? Well, according to our notes, the triangle exterior angle theorem states that the measure of each exterior angle of a triangle, so I'll circle the exterior angle of the triangle, so here's our exterior angle of the triangle, equals the sum of the measures of its two remote interior angles. So where are remote interior angles? I will put that in green. Okay, so here is one remote interior angle, and here's another one. So what does it say? It says the sum of the remote interior angles equals the exterior angle. So the sum of our remote interior angles equals our exterior angle. Okay? So what is our sum? So we can say that 100 degrees plus 30 degrees equals our measure of angle 1. Again, the sum of our remote interior angle equals our exterior angles. So we get the 130 degrees must equal the measure of angle 1. Just so that we remember, RIA is remote interior angles, and EA is our exterior angles.